Okay, geez, I feel like I've been waiting in line for a Disney ride after all that. It was my last minute scramble to get some royalty-free music. Test audio stream here. Um, all right, so this is well, what was originally just going to be a recorded movie. We're gonna try getting a device, brand new device here, um, to be recognized an input mapper and decode the HID signal for it. Uh, all right, we're gonna start off here. Um, If you're not familiar with the project, right now it's just been a DualShock 4 to Xbox 360 controller mapping, but we're in the middle of writing some framework that will open it up to a lot more devices pretty soon. And that framework will allow for third-party plugin development, which is what we're going to demonstrate how to go about using. Okay, so we're going to start here. If you go to our website, if you have a developer account with us right now, if you don't have one, you can just contact me through the forums here and get one set up. But you just want to go to your downloads here, and you will find the tools that we'll be using throughout this. Two things that we will be using primarily is the packet decoder and the IM2 SDK input device template. The packet decoder is going to help us connect to the device and actually look at the HID packets that's being sent, and we will use that to hello to Michael. I think I'm saying that correctly. But the HID device library is included in the packet decoder. So you won't need to download that separately. Alright, so we already have both of these downloaded and installed. And to do this, we're going to be using Visual Studio 2013 Community Edition. And this is completely free from Microsoft. So you don't have to worry about licensing anything. You can just jump onto Microsoft's MSDN website, grab this for free, and you will be able to do everything that you see here in this video. So, first step is we have the device paired, we have it connected, and what we're going to be doing is this device right here. It's a SteelSeries little mini controller. I use it, I throw it in my tablet bag because it's something small that I can take with me everywhere, unlike this, which is kind of bulky and it doesn't really fit my laptop bag too well. But the only thing with this is it has crappy software and almost no in-game support, so we're going to be writing the plugin to fix that right now. Alright, so we want to launch up our HID packet sniffer here. And this is a tool that I wrote, mainly because the other tools for sniffing HID packets are a little too cumbersome. They don't really give you the packet information that you need in a live view. So what we're going to do here is, if you don't already know your VID and PID of the device, that's your vendor ID and product ID. You can find that out pretty easily by going to your devices and printers. And you'll find the device in here. I'm going to go ahead and launch up the properties of that device. And we're going to go to the hardware tab. And you'll see a couple functions in here, and you see this one has a couple HID functions tied to it. We're just going to pick one here. I'm going to try this one because it looks the most generic. It doesn't have the brand name or anything in there. Launch that up, go to our Details tab, and in here, you'll see Hardware IDs. Alright, once you get that, you'll see a few options in here. This one looks the most complete, so it's the one we'll use. And you can see right here, you see VID, a separator, which is the ampersand, and then a string of numbers. And then you'll see PID, the ampersand separator, and then another string of numbers. For the most part, when connecting to devices, we only care about the last 4 hexadecimal characters. So in this case, it's going to be 1038 and 1412. So we're going to go back into our little device packet sniffer here, and sure enough, there's 1038 that it found, and 1412. And there's the device. We're going to go ahead, launch the device listener. And you see here, we get our report. This is a live view, and we also get the report length. So, if I go back over to my device here, and start moving the controls around, I'm going to see that it's starting to pick up live information here from the controller. We're getting, it's actually a byte array, so everything's going to be 0 to 255 values. And the array is 8 in length from a 0 base. Alright, so now that we have that and it's connected and we're getting good data from it, it start to actually decode what we're looking at here. So for that, I just pull up a notepad, set this to the side here so I can start jotting down things that I notice. And just from mashing on this and hitting the buttons, I can see that the channel 0 is a constant 1. So that probably just signifies either connection state or that the device is actually connected. So we're going to ignore channel 1 there, or channel 0 rather, and we're going to go directly to the channel 1. Alright, and that is my D-pad. And it seems to be a clockwise, yeah, it's exactly what it is, just clockwise, 0 being top dead, 1 being top right, 2 being to the right, 3 to the bottom right, and continues on around to 7, which is top left, and then back to 0. Alright, and nothing else seems to be tied into that. That is only the D-pad, so we can go ahead and note that down. Alright, and we're going to continue on to channel 2, which is a stick value, it looks like. That is the X value of the left stick. Okay. Alright, so center is at 0. But it does something funky here where it looks like the right hand throw is from 0 to 127, but the left hand throw is reversed. It starts at the maximum, which is 255, and then drops down to 128. So that's weird. We're going to have to write something in to recognize that. Usually it's linear, and it just goes from 0 to 255 with 127 being in the center. Alright, so we're going to note that down. So it starts off at 128. To 255. And then 0 to 127. And channel 3 is going to be our Y value for the left stick as well. And it looks like it does the same exact thing. I'm not exactly sure why they coded this device to do that, but it's easy enough to work around, so. Oh, I got my values shifted here. I should actually type them into what they are. Okay, yeah, so 3. It's going to be my LY. And it's going to be identical. And if there's any sense in this device, channel 4 is going to be my left or my right X, and that's exactly what it is. And it has the same exact split in the center. Just to get it out of the way, 5 is the right Y, and it does the same exact thing. Okay. Okay. Now on to 6. That looks like it's my button values for the face buttons and the bumper buttons. Okay, and that's a normal. That's a normal, looks like it's double in values. Okay. So that's an enumeration there. That should be easy enough to figure out. We just have to do some bitwise operators to get the shift of that. Alright. The order doesn't quite make any sense. We're also missing a value there too. Okay, so button 4, it looks like it's going to be 1. Let's see, the next one is button 3. That looks like that's going to be a 2 value. Next one in order is button 1, and that's going to be an 8. For some reason it skipped a value of 4, which I've been hitting buttons here and I can't seem to find it. So I'm not sure what they have that mapped to or why they skipped it, but we'll just move along. And 2 looks like it's 16. And this also has the shoulder buttons on it. Looks like we're skipping 32 and going right to 64. So my left shoulder is going to be 64. And right shoulder is 128. Okay, and we also have 2 center buttons here, which is on the pads you're familiar with. It's our start and back button, and it looks like those are going into the 7th spot on this report. So A is 16 and B is 8. Okay, so that's everything. That's the device. We've now decoded the HID packets, and we figured out what everything is. So the rest of it, actually mapping the device, it's code. So we're going to go ahead and launch up our Visual Studio here. Alright, we're going to create a new project. Alright, and if you haven't already done this, you want to go to our website and grab the IM2 SDK input device template. Grab that from there, download that and install it. And once you have that in there, when you go to your new project, you'll see it as an option down here. So we can go ahead, input device. We're going to name this the device, which is Steel Series. Okay, everything there looks good. We'll go ahead. Alright, so that created our project. Imported some of the basic references that we'll need for this, including the plugin interface reference, which is what the application uses to kind of standardize everything. And we have our first class here, which is named to the Steel Series. Alright, so what we got to do is, first thing you see in here, we got some red. We got to rename these things. For some reason, the plugins do not name the classes automatically depending on what you name the solution. Either that, or I just haven't figured out how to write a plugin to do that yet. So you will have to come in here and rename the classes and then rename the references to them. So we're going to call this free is the actual name of the device. Kind of weird. And you see I got a suffix at the end of these just so I can quickly differentiate them. One is the plugin and one is for the actual device. The plugin will handle the detection of the devices and the general start-stop operation, stuff like that. The device itself, that class is what will be doing the listening. Alright, so we're going to come in here. This is actually an input device. And we're going to have to rename our constructors to match. Okay, and then the collection of the devices, we're going to have to put the correct type in there. Actually, we want to keep it generic, so we'll type those as just regular input device, even though the Steel series is going to inherit from that. And we need to do that all the way down there. And that looks good. Okay, so everything's caught up now. We're going to go ahead and call this. We'll skip the description. All this stuff is pretty self-explanatory. It's a good idea to fill it in because that's what the application will use to actually differentiate the different plugins and everything. Okay, so now that we have all that in there, it's time to start the actual coding. Alright, since this is an HID device, we have a library already set up and ready to go that's available on our website to handle most of the HID interactions. So we're going to go ahead and bring that library in. See if it's under my recent. No such luck. Okay. But here it is in here. Okay, HID devices.dll. Bring that in, and we'll reference it in here. There it is. Okay, so now in the actual plugin, we need to go ahead and detect whether or not these devices are running. So what we're going to do we're going to create a new class in here, which is going to do our checking for us. And make this private. And the first thing we're going to do is we're going to enumerate the devices that we have connected that match the HID and PID that we discovered this device uses. So there it is. And this is a type that's contained within that library that we just referenced, and that'll contain all the general information about the device as well as its connection handles and overrides to actually send and receive packet data from it. But we're going to create this numerable list here from the search results. We're going to call this we're calling it devices found because this is not our actual connected devices yet. That's stored in this enumeration or this collection here. This is only the devices it's going to find during the search, and then we want to enumerate through the list here and determine whether or not we're already connected to it before we just go ahead and blanket perform an action on all of them. So we're going to go back and reference our library again here. Let's see. And we are going to enumerate. And there is an overload here where it asks for a specific vendor ID and product ID. And this is the one we're going to use here since we already know both the vendor ID and product ID. So I'm going to pop up my device finder again here just so I can have it and reference that. So vendor ID and product ID. Alright, and that'll give us our list of devices. Now we need to enumerate through that and see if it's already a found device. Alright. So now we have our enumeration here. Oh. Oh, okay, here it is. I have the wrong type to find. Alright, back in our actual device handler here, we're gonna need to store that HID device reference there, because that will be doing our actual listening here. And we're going to keep that a field. I'm not going to make that into a property. That way I can quickly define it. So for each found device here, and this is why I kept it a field, because that way I can quickly just reference that here. And add it in. Alright, so that will already go ahead, that's reaching out and that's finding all the devices that match the hardware ID, the vendor ID and the product ID. It's creating a enumerable list here in this class, and then it's go ahead and it's enumerating through that list and creating an instance of the actual device class for each one. Alright, now what we need to do is this check for devices. We need to figure out how that's going to run. So we want it to run once on initialization, just to see if there's any devices already connected. So we'll add that in here. And then we also want it to run every time that a device is hot plugged. So to do that, We're already using the input mapper software reference. There is a event that we can hook to that will run that. So we're gonna I can remember where I have that in here. Here we go. Hardware change detected. We're going to hook to that event. And we're just going to go ahead and have the event. Call that method. So now every time that a device is hot plugged into the system, it'll go ahead and rerun our check. But the problem there is, since this is just blindly adding every device that it finds, it'll start adding duplicate devices in. So what we need to do there is we need to have a link expression to go through our devices list and skip it if it already exists. And since this is since this will be an actual new instance, since we are creating a new enumeration, we can't just compare the two instances. So we will have to compare a property within the instances to see if they are actually equal. So to do that, we are going to go into the actual devices enumeration. And we're going to use some link here. Since this list is the generic input devices, which this class is inheriting from, I don't have the access to the actual HID field, so we're going to have to cast this before we can actually do what we need with it. Just copy and paste this up here. Right now, there it is, HID device instance. That's what I was looking for. Now within that class, we have a couple options open to us. If the device uses several different methods of communication, the actual serial is going to be your best bet for comparing, and that's just the MAC address. And the MAC address will remain the same if it's Bluetooth or if it's USB. In our case, we are only using it via Bluetooth. The device doesn't have any USB capabilities. So device path works for us, and it's a little bit quicker. So we're going to go ahead and we're going to say where the device path does not equal our found device's device path. And we'll go in here and we'll count the records that match that condition. And if there are any, or if the count is higher than 0, that means it doesn't already exist in our found devices, and we'll add it. So there, that'll keep our duplicate devices from showing up. That way we only have one instance of each actual device contained within the device's enumeration. So now that we have all that done, it's time to actually get into the device listener itself. So we're going to come down here. We can skip a lot of this stuff. We do need to set up the input channels. So we already know what channels the device has. And this is a dictionary, string and input channel. The string can be anything you want. It's just how we're going to be referencing it throughout this class. So it's easy to name it to what the device buttons actually say on the face value or what they are. Okay, so that's the general format we're going to be using here. And starting with our face buttons, we're going to have button 1. And that's going to be a button. And we got 4 face buttons. We also then have A and B buttons. We got our D-pad. Let's see, we got our shoulder buttons. And I think that takes care of the buttons. Now we have a couple joy axes to consider here. So we're going to change the input type here to axis. And we're going to call this LX for our left stick x-axis. And then LY for the y-axis. And then we also have a right stick. So we're just going to duplicate this over. Okay, there we go. The device and its channels are now defined. And close this stuff up. Alright. We are going to create a constructor for this. And what that's going to do is we're going to go to our actual HID device reference here. And if it's not open, we're going to open it. And that starts communication with the device. Oop, okay, that's a field. There we go. Okay, this is looking for whether or not it's an exclusive mode. So, sure. We'll just force it into exclusive mode there. Alright. Now we also want to catch whether or not the device is paired, but it is not responding. Alright. And that'll avoid the device from actually just sitting there idle if it's not actually being used. So now that we connected to the device, we actually need to start looping through the device and catching its packets. So to do that, we're going to create a new method here, which is actually going to be our listener. So alright. And this is going to be a separate thread. And we're going to have to reference our system threading. Alright, so what that does there is that actually just creates our listener in a separate thread, so it's not eating up the application's thread resources. So now that we're in here, now we're actually going to start working with the report. And to first get the report, we need to actually define the byte array that it's going to land in. And we already know the size of that report from using our device listener, and the report length is 8. So we're going to go ahead and define that in there. Alright. Now we need to create a while loop. And instead of just having this run forever, we're going to go ahead and say while it's connected, we're going to loop. And that'll just keep it from running away if we suddenly disconnect it and don't dispose of the thread properly. Alright, now we need to actually grab the report. And what this does is it'll actually store a success failure variable, depending on whether or not it was able to read the report. And we need to actually throw the report in there. And there you go. It'll now loop through and keep grabbing reports from that device. Now the read file is a blocking line of code, meaning if the device isn't sending a report, it will halt here and wait. So this actually won't run away on its own and eat up all your system resources. So that's good. So if the device is idle, this will sit idle. So now we need to make sure that we actually got a valid report and that it didn't fail. Alright, now to actually start handling the data and storing it. So let's start with the sticks, since we saw those were kind of funny how it liked to split up the left and right, and it looked like it even inverted the axis too on the Y. So we're going to open up our notes here on the side so I can reference them. Alright. Yeah, LX. Alright. So our LX is spot 2. Now normally I could just store it directly there, but since we saw that it's split in the left and right axis, I'm also going to have to add in an inline conditional here. Let's see, so if it's higher than 127, we know it's the side that is reversed, for some reason throwing backwards. So we're going to subtract it from 255, and that should throw it back into the right order. Oops. Then we need to actually reverse the entire axis. And the right-hand throw was proper, so if it's on that side, I think we can use that directly. Okay, that should work. And since they were all like that, we can just copy and paste this guy. Left Y, right X, right Y. Alright, that left Y axis was on report 3. Right axis was on 4. And the right Y was on 5. Okay. So there we go. We got all of our sticks going in. It's storing them. One thing I forgot to mention is when we're defining these channels here for the sticks, we should also define minimum and maximum values here so it knows what the throw percentage is. We can do that inline here. And since they are all bytes, the max is going to be 255, with the minimum being 0. And all axes are going to be the same. Okay. Alright, so there we go. We're sucking in the left stick and the right stick, both axes on both sticks. That should loop through and store the values. Now we should already have a running application. This should be good enough to go. So I'm going to go ahead and check this to make sure it builds for now. Oh, failed. We already have a constructor somewhere. Ah, that I do. Where did you come from? Try that again. Hey, success. I like that. Alright, so I'm going to go ahead and throw this in to the to what I have of the application so far. So we're in Steel Series, and there's the plugin DLL. I copy that. Go back to my input mapper. And I'm going to clear out all the other plugins except for the input monitor. I want to keep that. And we can clear that out too. Alright, so now I'm going to launch input mapper. Oop, that actually recreated all the plugins again. I did not want to have all these going. Try that again. And I'm on another screen here about to launch the input mapper, but I want to take off these references so it's not rebuilding all those plugins again. So give me just a second here. Oh, I still got the DualShock 4. Okay. Yeah, whatever. We'll keep that one going. Nope. I know what I'm missing here. The HID library. I need to bring that with it as well. Okay. Now it should build. There we go. Okay. Alright, yep, it's up, it's running. But it is not detecting the device. Oh, we seem to have hit a snag here. Okay, this logic here might be a little off. And all right. You know, I wonder if this has something to do with it. I still have the device open over here. And I did want it to be connected exclusively. So maybe I should make it not exclusive. Let's give this one more shot here. Hmm. Let's try switching this back. No, that's right. Okay, so the exception I'm getting here is it's telling me my device is null when I'm trying to access the is open. So I mean, for some reason this isn't passing, isn't initializing when I'm passing the value in here. And I thought this would go that this would be stored in there before the actual constructor, but maybe I'm wrong. It's been known to happen. So what I can do is we actually have another method here called start device, which launches a little bit lower down the chain here. So I can take that out of the constructor and put that into the start device method. Can't return from that. Actually, we can return, we just need to send a bool with it, since there's a return type. Okay. So let's build that, copy it over again, see if we get any farther now. So what I think it was doing is the construction order for that class is a little out of order from what I was expecting. I think it was trying to access that variable in the constructor here before it had actually initialized it from this. So this probably takes place after the constructor, which makes sense because this is going to initialize your constructor here, and then this is going to happen and store it. So that's probably where my issue lies. And if not, I have no idea. We'll figure it out though. So you're learning, I'm learning, we're all learning here together. All right. Well, okay, there we go. All right, we don't have any icons. It doesn't look pretty because we haven't defined that, but who cares? All we care about is getting the control inputs to register. So we're going to launch the monitor device, and there's the device. Oh, another exception. We're getting a null for the icon. It doesn't like that icon doesn't exist. So the device needs an icon. Otherwise, it just won't work. So, turning a blank isn't an option. Alright, so we're going to create a resource file. And what does it want? It wanted a bitmap, right? Image source, which we can do from bitmap or icon or anything, basically. Okay. Let's see what I have. I know I don't have anything that directly resembles this device. Let's just pick some here. Sure, we'll go back to our roots here. We'll use the old DS4 tool logo. There we go. We need to make that public, probably. Save that. Okay. What is our class? Steel series or namespace. Plugin, resources. There's the logo. To image source. That's an extension method that's part of the framework for this tool. So you'll have access to that once you reference the ODIF namespace. So that should fix most of our problems. For shits and giggles, we'll go ahead and name the device. And then to make it unique, we'll go ahead and put in let's use the MAC address. Okay. Hey, we're going to give this one more shot here. Alright. There it is. There's our awesome icon. Okay. So those errors that were being thrown, they were part of the application itself, the input mapper application, which is still under development. So I'll add handles and null reference checks and all that stuff in to the application, so it's not so much of a burden on the plugin developers. All right, let's see if this works now. Hey, okay. All right. Unfortunately, it is not actually stuck. Hey, it's always something, I tell you what. But it is not registering inputs, even though supposedly it is connected to the device. I wonder if it's dropping out of this prematurely. Let me go ahead and set this to always running, and then we'll just rely on aborting the thread elsewhere. Nope, still nothing. Maybe that code needed to be in the constructor. I just need to figure out how to... Alright, let's try passing this device reference inside a constructor. See if that works. bring all this up here and back. Okay, now okay, so now it's going to find the device. Alright, so it's creating the instance. I know it was adding to the devices list because it was showing up on input mappers found devices. So it just looks like it wasn't initializing or starting properly. And I think it went back to me not having a proper device reference. It was creating it out of order again. So hopefully creating a constructor, an override that has that device in there, will actually do it in the proper order or force it to. Build it again, succeeded, that's always a good sign. Once more into the fray. Okay, this looks better. We have the MAC address in there. Alright, let's go to the monitor. Okay, yeah, alright. Those values aren't correct, but it is registering. Okay. I don't know why they're sitting down there at 0, though. They should be centering out. Okay, the minimum value is 0. And the default that this likes to pass is 0 because that's where it sits when it's not at an actual value. Okay. Let's try this. Max value at 127. And the minimum at negative 127. Because the math I'm using here is centering it at 0. So my access definitions should be centered at 0 as well. Alright, let's see what that does for us. It's been used. Stop. Why are you in use? Why would it be in use? Can't be in use if you don't exist. What the hell? How is that even possible? It doesn't exist. I deleted it. This might be a Visual Studio bug. Close out of this. Yeah, let's get rid of some open windows too. Try that again. That makes no sense. What could possibly be using it? There we go. Okay. I had another debug environment running, so that was interfering with it, it looked like. Okay. Yeah, okay, that looks better. The y-axis is reversed. So is the x-axis, actually? No, the x-axis feels right. That's low, high, low, high. But the y-axis is definitely reversed from what you would think it would be. So that's simple enough. We just need to jump in here. And reverse the whole darn thing. Alright, so. And we now have our left and right stick axes. Onward. Onward to buttons. And here we do our bitwise operations and our shifting and all that stuff to turn this mumbo jumbo into bool values. Alright, so controllers, as you found out when we were debugging the packet earlier, controllers like to store a bunch of different buttons onto a single byte within the array, just to save a whole bunch of space so we don't have an array full of just true and falses. Otherwise this packet would be like 3 times the size. Alright, so since we went ahead and found the value for each of the button presses, we can start creating our bitwise operations for it. So let's start with our probably face buttons. So I'm going to start with B1. That's what I called it, right? Yep, B1 through 4. The controller literally, it just says, here, I'll show it real quick since I don't think I have. The face buttons on it are literally just 1, 2, 3, 4, A, B, L, and R. So I'm keeping the naming standard the same as the actual controller itself, just to make it easier for me to tell if something isn't mapping correctly. Alright, so we're going to start with button 1. And let's pull that back up. See, button 1 had a value of 8. So and that was on, let's see, report channel 6. Alright, so this is how bitwise operations work. Alright, so in an enumeration of byte values, each iteration of the enumeration is going to be the value doubled. So the first value is going to be 1, and then 2, and then doubled, so it's going to be 4, 8, 16, 32, 64, and it goes on and on up to 255. Since it's base 0, 256 is actually 255. Alright, so we have that, and because of this, that one numerical value can actually store as many different button combinations as you can fit into a byte, because no two combination of numbers will ever equal another two combination or single number in this list. So if I have, for instance, say button, this is in order from button 1, 2, 3, this is the third, fourth, fifth, sixth, seventh. So if I have button 2 and 3 pushed at the same time, it's going to be a total of 6. Right? There's no other way to get 6 in this list unless it's button 2 and 3 pushed. So that's how bitwise operations work. So what we're going to do here is we are going to shift that byte. We know that button 1 had a value of 8, which on a 0 base count, 0, 1, 2, 3, 4, 5, 6. We know that a byte value of 8 is third in our list in enumeration. So we're going to shift it left by 3, and if the value does not equal 0, then we know that that is one of the buttons pushed on that list. It's all complicated, but all you really need to know is if the button has a byte value of 8, which is the third on the list, then you need to shift it by 3. Alright, that's all. That'll cover all of your buttons for any device. That's all you need to know about that. So, we're going to continue this on and do our other face button values. 1, 2, 3, 4. Alright, so button 2 has a byte value of 16, which is fourth. So we're going to shift it by 4. Button 3, this is weird, they're out of order, has a byte value of 2, which is first on a list of 0 base. So, 3, okay, yeah. And then 4 has a byte value of 1, which is at 0. So, I'm not exactly sure how to handle zeros. I don't know if you shift at 0. Shifting 0 would essentially be no shift at all. So I'm wondering if we just get rid of this, or if we actually have to implicitly say shifting 0. Let's build it. Let's find out. Okay, so button 4 is correct. Uh-oh. Button 3 and button 4 are showing up there. Button 4 looks like it's always coming up no matter what. So maybe it does need that shift. I'm pretty new to bitwise operations, so I mean, this kind of figuring this stuff out through trial and error. Still had this open. Yes, that didn't build right. There we go. Okay. There we go. Okay. Yep. You do have to still explicitly show that shift. Okay, so 4, 3, 2. All right, yeah, so those buttons are all mapped properly. Awesome. Cool. All right, and the other buttons are the same, so we're going to skip that for now and go directly to the D-pad. There's a little bit stuff we got to do for the D-pad, seeing as how the report is showing a clockwise order representation of a 8-directional D-pad, but we only define 4 values in here. So we need to turn that 8-direction byte value into cardinal directions, our north, south, east, and west. So go ahead and stop that again. What we can do for that is we're just going to do, I'm sure that you can do all kinds of bitwise operations for that too, but we're going to just do conditionals. We can do it in a single line of code, and it'll be easier to see and understand. Let's see, is that how I have that formatted? D up, yep. Alright, so we're going to pull up our notepad here again. Alright, I'm going to do some little fancy text illustration here. Oh, okay, yeah, I skipped a number. Sorry, it's a little early for me still. Okay, so that's our clockwise representation of what the D-pad directions are. 1, 2, 3, 4, 5, 6, 7. Alright, so what we can do here is if our input report, let's see, that D-pad is on channel 1, towards the beginning. Okay. So what we can do here is just some conditionals. If report 1 equals either 7, 0, or 1. Alright, so what that's saying is that if it's returning a value of 7, 0, or 1, then the up button is definitely at least one of the directions being hit on the D-pad. So that'll make it true. And that's just storing the if return of that directly into the bool value of that. So we're going to do the same thing for each of our cardinal directions here, but we're going to change the numbers. So we got our up, we're going to go clockwise, right, down, left. Alright, so to the right, we would have 1, 2, and 3. Down, we would have 5, 4, and 3. And all hats are pretty much the same that I've seen. They're always this, clockwise representation. 7, 6, and 5. Okay, so save that. We're gonna build that. Yep, looks good to me. Alright, so I'm going to go ahead. I'll turn the camera back on here. Alright, so if I hit up, only up highlights. But if I hit up and right are both highlighted. If I just hit right, just right will light up. If I hit lower right, down and right, and it goes all the way around. So that's how you do a D-pad. Alright, so you've learned how to do axes, buttons, and your D-pad. And those are the basic controls that you will need for any device. Doesn't matter what it is, the DualShock, the Xbox controller, they're all pretty much follow the same standard. If not, you will run into devices that have, special packet information such as the DualShock's touchpad, which does all kinds of funky stuff with its packet reports. So it's just going to take a little bit more effort decoding what each of those values respond to, such as like multiple touches and multiple touch locations and all that stuff on the trackpad on the DualShock 4. But if you got the patience, you can figure pretty much any device out using this method. Alright, so that was it for this stream. Well, I mean, it's going up as a video onto the website and everything as a tutorial. The stream was just for the most part to test out the format and whether or not, might be a viable option for the future. Maybe we'll do some other coding stuff, like I'll order a new device every week or every couple weeks, and we'll sit down and figure it out together. I'll also be putting up videos showing the more advanced features of this plugin interface, such as the localization options, and we'll sit down and get into doing the state icons and adding application plugins, where you can add menu items and whole nother windows. This device monitor is actually a plugin. You can see here the input monitor, so we can go through how to write stuff for all that. The input mapper program itself, version 2.0, that uses these plugins, it's obviously still heavily in development, since you saw some of the errors we had to fight through just getting this plugin written. But it is coming along a little bit more every day, so hope to have it out. I want to be demonstrating it at a couple trade shows this year. So hopefully, next couple months we should get a release candidate and a beta out for people to play with, and at least start, being able to write plugins and have access to this kind of stuff in there. But for now, stuff like the packet decoder and this the framework and all that stuff is available on the website. Just get in contact with me through the forums, and I'll create a developer account for you, and that'll get you access to those downloads. If you have any questions about it, obviously, we weren't able to go into everything in this video. There's just too much going on that we could possibly get into in a video. But yeah, if you want to get in contact with me, if you have specific questions, or if you got any ideas how to make the framework a little better, or more compatible with more devices, add features, functionality, just get in contact with me through the forum. So that will do it, I think. Yeah, okay. So I am going to leave you guys with some more horrible Disney World wait and queue music while I shut down the stream. Hey, as soon as I find that stuff. Here it is. Let's listen to that.